Hey, so today we're talking about proportional thinking. And here are our learning objectives. We're trying to apply concepts of ratios and proportional thinking in real life concepts. We're trying to solve these problems usually with pictures and understanding that percentage is a ratio and vice versa. And then we're going to look at real world problems and try not to get deceived by real world problems. So here's a question. I have this picture on the right. It is a rectangle. It measures 2 units high and 3 units long. And I just kind of put a grid here in the background so that you can see that indeed it is 2 units high and 3 units long. So I want to put this picture in my living room, but right now it's too small. So you can imagine that this is kind of the wall that I want to put it in. So I decided that I want this to be 4 units high. And so I know that I need to buy the picture frame that is 4 units high, but I don't know how long it should be. So take a second and think if I took this picture and blew it up, how to make it 4 units high, how long would that make the picture? So hopefully you thought about that for a second. And so what you can see is a feature that I know all of you guys have used on your laptops or computers is the feature where you can hold this corner button and it will move the picture proportionally correctly. So you can see here that I'm going to drag this corner until it makes it 4 units high. See, now this picture is 1, 2, 3, 4 units high. And what did that make this? This made it 1, 2, 3. It was 3 or 4, but now it made it 6. So what it did is it took this 2 and something that we're going to talk about in a little bit. The way you want to think about this is it didn't add another 2. It took the original 2 and then multiplied that by 2. We can see that here because we had the original 3 and then we multiplied it by 2 to get 6. It's not, oh, we add 2, so then we add 2, right? We need to keep the proportions of this picture correct. If I made this 4 high but only made this 5 long, it would be all warped and funny, right? So to keep it proportionally correct, you want to think of multipliers. So ratios and proportions are multipliers, not additives. So let's look at those two words together because a lot of people use it interchangeably and they're actually different things. So a ratio, here, let me highlight this for you. A ratio talks about you're comparing one number to a different number. You're comparing something to something else. It's kind of a comparison or a relationship. So you can say the ratio of Angels fans to Dodgers fans is 2 to 3. So see this 2:3. This 2 was the first thing I said of Angels fans. So there's 2 Angels fans for every 3 Dodgers fans. So I'm comparing Angels fans to Dodgers fans, like I'm comparing them against each other. Another way is you can often write it as a fraction. So the ratio, still call it a ratio even though it's a fraction. The ratio of Angels fans to Dodgers fans is 2 to 3. Again, how do I know who's in the numerator, who's in the denominator? This 2 here is what separates them. So it's Angels fans is the first thing I see, 2, the division sign, and then Dodgers, 3. It was the same thing over here. Angels fans, 2, and then 2 Dodgers fans, 3. Okay? And it's very important that you say the words and then write this in the correct order. If I said Angels fans to Dodgers fans and then wrote them in the other order, it can get really confusing. So to keep things in order, we're going to put them in the right order. And then a proportion is a statement that you make that says two ratios are equal. You're comparing, instead of comparing two things like a ratio does, a proportion compares two ratios. So for example, here it says, Carl can type 8 pages for every 4 pages that Dan can write. This right here by itself, that phrase right there, that is a ratio, but that's not the entire thing that we're talking about. It then says if Dan has typed 12 pages, how many pages has Carl typed? So the entire thing here, this whole statement is a proportion. You're taking this ratio and comparing it now to this other ratio. So you can see here, this is 8 pages to every 4 pages. That's my ratio here with a fraction. And then it equals, because the proportions do, you're setting two ratios equal to each other. And then you're taking the 12 pages, which is down here at the bottom right. How many pages has Carl typed? So in math speak, what we're saying is these blue phrases here, it's 8 is to 4, 8 is to 4 as equal sign. 24 is to 12. So the answer here is that this x has to be 24 in order to get that to be correct, right? So that's the difference between a ratio and proportion. You'll hear that interchangeably, but it's not the same thing. So let's focus on ratios for a second. When you're talking about ratios, when you're comparing two things, you need to be very specific what you're referring to and who you're comparing to. So like we said earlier, you have to make sure that the words are in the right order to match the numbers. That's one example of this. There's other kind of examples we'll see in a second. What you choose, the numbers that you choose, depends on how you set up the words, or vice versa, depending on how the words are set up will change your numbers. So here's an example. I've taken 3 parts. We just say that they're cups or something. We're taking 3 parts of water, so 1, 2, 3 here, to 1 part of bleach. So there's 1, 2, 3, 4, 5, 6, 7 different ways to say this picture in math. Okay. So one is the ratio of water to bleach is 3 to 1. There's 3 parts water to the 1 part bleach. In this example, we're comparing a part of this whole thing, a part of this whole system is water, and another part of this whole system is bleach. So I'm comparing this part to this part. We could also say the ratio of water to the total mixture, the total system, is 3 to 4. How many parts are in this entire thing? There are 4 parts. So there are 3 parts of that whole thing is water. So that's what this is saying. The ratio of water to the entire mixture is 3 to 4. That's a part to a whole. This is the whole thing is 4. 3 parts of that is water. You can take the first one and you can change the words. So instead of saying the ratio of water to bleach, you're going to say the ratio of bleach to water. Now, if you flipped the words, what are you going to do? You're going to flip the numbers. So now the ratio of bleach to water is 1 to 3. There's 1 part bleach to 3 parts water. So it's very different. You have to be very careful. You can't take the same one and put it here. You've mixed the words, you have to change the numbers. Then the ratio of bleach to mixture is 1 to 4. So just like the one up here, you're comparing a part to a whole. You're looking at the bleach. There's 1 part bleach, and there's 4 in the whole part. So the ratio of bleach to mixture is 1 to 4. You could also take the ones we're comparing part to whole, and you can make them a fraction. So you can say 3/4 of the 3/4 of the mixture is water, right? So you can see the whole mixture is made out of 4. 3 of them is water, so 3/4 of the mixture is water. You can also do the same thing with the bleach. 1/4 of the mixture is bleach. The quantity of bleach is 1/3 the quantity of water. This one's the one that messes up people the most. Notice that in these above ones, oh, the entire mixture is 4, so there needs to be a 4 in the denominator. Well, if you're using a whole. If you're just comparing parts, you can say that 1 part of bleach to 3 parts water. Well, you can say the quantity of bleach is 1/3 the quantity of water. So you have to be very specific how you say the words because it's going to change your math. It's going to change your numbers. So here's a question. I am making different batches of chocolate chip cookies. Here are 2 batches. Batch A has 4 cups of batter. So here's in my little picture, this is 1, 2, 3, 4 parts or 4 cups of batter. And I added 1 cup of chocolate chips. In the second one, in the batch B, I have 6 cups of batter, 1, 2, 3, 4, 5, 6. And then I added 2 cups of chocolate chips. So now let's say that I'm going to keep one of these batches and the other batch I'm going to give to you. And I'm going to let you pick the one you want. I typically don't like a lot of chocolate chip cookies. You do. So I want you to pick the batch that is going to be chocolatier, right? Which one has more chocolate chips in each cookie as a ratio. So there's a couple different ways to do this. I like to do this with pictures. And in my experience, most people like to do this in pictures. So one thing that I like doing is I like to see, oh, there's 4 parts here, 1 part here. And I like to see if I can maybe make these parts the same. So again, just like the picture from before, we can't add. It won't keep the ratios, and we have to multiply. Ratios are a multiplier. So if I take this 4, oh, maybe I can multiply by 2. Well, that gives me 8. That doesn't give me the 6 here. Another way that I can think about it is, well, what if I just instead take this 1 here and multiply it by 2? Then I can get this correct multiplier. So I want to compare these two. I'm going to take this part, and in order to get the same amount of chocolate chips, I need to double this original amount. Okay, so now I've doubled it. Now, have I changed batch A? Yes, I have. I've doubled it. But have I changed the level of chocolatiness in the chocolate chips? No, it's still the same amount, right? I've just doubled it, right? For example, back in this picture here, I haven't changed the picture. I haven't warped the picture at all. I've just like zoomed in this picture, right? I've blown it up. I've made it bigger, but proportionally it's the same. So you can think of the same thing with these chocolate chips. I haven't changed whether or not they're chocolatier. I've just kind of made more of the same thing, right? In the same quantities, in the same amounts. So now I can say, okay, well, I have 2 cups of chocolate chips here and 2 cups of chocolate chips here. So now I can directly compare. They're the same chocolate chips. Which one has more batter? A has more batter here, right? I have 8 here and 6 here. So I have the same amount of chocolate chips, but this one has more batter. So now, which of these is chocolatier? B is chocolatier. You have the same amount of chocolate with less batter. So in this case, B is my answer here. There's another way that I like doing this. What this is saying is for every 4 cups of batter, I have 1 cup of chocolate chips, right? If I want to keep, sorry, the chocolatey intensity the same, I can keep adding to this mixture A as long as the ratio is correct. So for example, if I wanted 8 cups of batter now, what would I have to do? Well, here I just multiplied by 2, right? It's the exact example that we just saw. So I'd have to multiply by 2 over here also, and I'd get 2 cups, right? But that number can be anything. I can multiply by 3. 4 times 3 is 12. And so here this would be 3. So I can have 12 cups of batter and 3 cups of chocolate chip. And the chocolatiness is the same. And better yet, this multiplier doesn't have to be a big number. It can be a smaller number. So what if instead of multiplying by 2, I now multiply by a half? Instead of zooming into the picture, I am zooming out of the picture, making it smaller, right? So here is a half. Gives me 2. And if I multiply that by half, that's a half. So in other words, 4 cups of batter to 1 cup of chocolate chips is the same as 2 cups of batter to half a cup of chocolate chips, right? Imagine I made this amount of chocolate chips, but you're like, you know what, that makes too many cookies. I want less. I want half that cookies. What would you do? 2 cups of batter, you'd half it, and then you'd half the amount of chocolate chip. So this will help me get to the same amount in the batter mixture. So I can take this 4, and I have this 1, and if I want to make this 4 6, I need to take this extra 2. I want to like have an extra 2, right? Okay, I can do that. Here's my formula to do it. Here's the 2 that I want. Oh, but I can't have a whole chocolate chip. What do I need? I need half of a chocolate chip, half a cup of chocolate chips, right? So I'm just going to come here, cut this in half. So I can go ahead and add on this amount. Nothing has changed. Everything is still okay, right? I still have the same level of chocolatiness because I multiplied it by the same thing. So now I can directly compare. It's a little bit harder to do this because 4 to 6 was not a very nice multiplier. We have fractions now. It was easier with the chocolate chips, but I want to show both ways how you can do this. So now I have, let's double check, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have the same amount of batter, the same cups of batter, right? In the same quantity of batter, you can imagine the same bowls here. In bowl A, I only add a cup and a half of chocolate chips, but in bowl B, I add 2 cups of chocolate chips, but I started with the same amount of batter. So now it should be very obvious. B is chocolatier, has more chocolate as a ratio to the whole system. So you would take batch B and I would keep batch A because I do not like a lot of chocolate chips in my cookies. And then I just want to point out a couple of very common mistakes that I see in here semester after semester. So I understand where these kind of thoughts are coming from, but we want to nip them in the bud as soon as we can because these are not correct ways of thinking. So here's a completely different example. Same A, 4 cups of batter, 1 cup of chocolate chips, but now I made a whole nother batter because I'm just the cookie monster right here. 5 cups of batter to 2 cups of chocolate chips. This is what I've heard, and it's incorrect thinking. These ratios should be the same because we've added the same amount, 1 cup, to both the batter and the chocolate chips. So here they say, from 4 to 5, I add 1, and from 1 to 2, I add 1. So the ratio is the same. That's not true. It's not, the mistake was in the fact that they were like, oh, I'm going to add 4 plus 1 and 1 plus 1. But remember, we have to keep the ratios and proportions the same, and in order to do that, it needs to be a multiplier. The last incorrect thinking that I see very commonly is, oh, the second one has to be chocolatier because it physically has more cups of chocolate chips. Basically, they just see, oh, this one has 1 cup of chocolate chips and this one has 2 cups of chocolate chips, so E is automatically the winner. E might be right, but that is an incorrect way of thinking about it. That can't possibly be right. Right? It depends on the batter. You can't just look at the chocolate chips by themselves. If you find that you are adding from one number to the next, or you're just looking at one part of the ratio and not the second part, I want you to stop and I want you to think, okay, this is incorrect thinking. Let's try a different way. Let's try a different strategy. So now let's think about proportional thinking for informed citizens and consumers. Let's use this ratio and proportion to help spot some fake news because advertisers love to do this. Well, so we're going to play a game. I'm going to show you a picture. I'm going to show you this picture only for a couple of seconds because I just want to get your initial thoughts, okay? No staring at it too hard, nothing, just gut reactions here, okay? And you're going to tell me, well, or at least say out loud, what your initial gut reaction is, okay? So I'm going to show you a picture. It's going to be on the left-hand side. I'm going to describe it for a second, and then I'm going to ask you two questions. And as soon as I ask the question, I want you to say out loud what you think. Ready? Here's the first picture. This first picture is the percent of students who prefer coffee to tea. Here's CSULB, CSUF, and Dominguez Hills over here. So here are the things I want you to answer. What is the first thing you think of when you saw this? What do you think this picture is trying to say? Good? Okay, just initial thoughts. We're moving on. Ready for the next picture? Boom. This is also the percent of students who prefer coffee to tea, CSULB, CSUF, and Dominguez Hills. So now ready? What did you first think of when you saw this? What do you think this picture is trying to say? Got it? Gut feelings aside? All right, here are the same two pictures side by side. Now let's actually take our time. Let's take a second and look at these side by side. And now let's actually look at what they're saying. First of all, let's look at what they have the same and different. This top up here, percent of students who prefer coffee to tea, is exactly the same in both of them. CSULB, CSUF, CSU, Dominguez Hills are the same in all three of them. So what's the difference? Well, pictorially, this is very drastic. This isn't very drastic. Is one of them lying to me? Is one of them telling me, like, how am I supposed to know which is true, which is not? They're the same picture, but warped in such a way to make you feel one is supposed to elicit a very strong reaction. This one doesn't seem very drastic, right? They're all relatively equal, right? CSULB have a problem. Do they like more coffee than tea? Yeah, absolutely, right? Like you can see this here. But this looks so crazy drastic. Is this picture lying to us? No, this is saying 62% in CSULB, and this looks about 62%. This is 54%. Here's, yeah, 54%. And here's, so what's the deal here? Notice the scale. This starts from 0 and goes to 70. This is scaled in increments of 10 from 0 to 70. This shows you the whole picture. This is showing you, this is super zoomed in to this teeny tiny, in between the 60 and the 70. Actually, no, in between the 50, from 53 to 63. This zoomed in to 10% of this scale, right? This is showing you 62%, 54%, and 55%. This is only an 8% difference, but it takes up the entire screen. This is only a 7% difference, but this difference is zoomed in so much that it takes up the whole scale that it makes you think, wow, CSUF really likes tea. Nobody likes coffee over there. And if you don't pay extremely close attention to the percentages and what they're trying to tell you, it looks very deceiving, right? So while both of these give you the same information, one is kind of worded in a way, or I guess shown in a way that makes it seem very drastic, whereas that might not be the whole picture, right? This is showing you the whole picture. And you want to look out for these things. You know, this is not an uncommon thing. This is something that shows up on the news. This is something that shows up in marketing, and we'll see a lot of examples of this. So let's talk about a percentage, right? One of our goals here was to look at percentages in terms of ratios and proportions, right? So let's talk about what the word percent means. The word percent literally means for every 100. It doesn't seem very obvious that per 100 came out of percent, but it's very obvious if you know a different language, especially Latin. If you know Spanish, you say percent por ciento, right? Which makes it very clear that it's por cada cien, right? For every 100. So percent means per every 100. So n% just means you get n of them for every 100. When we use the word percent, it is very important to say what we are talking, what the percent of what, right? You can't just be like 6%. Okay, cool, 6%. 6% of what? Like, what are we looking at? 6% of monkeys? 6% of what, right? Just like in ratios, where it was very important to say what you're comparing, is the same thing with percent. You have to say blank or n% of what. So let's look at an example here. For example, let's say, for example, we have 27 out of 45 students are Dodgers fans. So we found 45 students randomly walking around campus, and 27 of them claim to be Dodgers fans. Okay, So if 27 of them are Dodgers fans out of 45 of them, that means 18 of them were not. And then I got these percentages. Where did these come from? This percentage came from 27 students out of, what were the total number of students? 45. So as a percentage, that comes out to be 60%. And the same thing happens with these 18. I got this 40% from saying 18 out of the total 45 students are not Dodgers fans. So that's 60%. So again, saying 60% by themselves doesn't make sense. We have to say 60% of the students are Dodgers fans. Where did the 60 come from? We didn't ask 60 students. 27 of them said they were Dodgers fans. Where did the 60 come from? What it means is if we were to ask 100 students, if we kept going and asking more students instead of just stopping at 45, if we went to 100 and the preferences stayed proportionally the same, right? We're guessing that they do. Then out of those 100 students that we surveyed, 60 of them would be Dodgers fans. That's where this number 60 comes from. And so we could say the same thing with 40%, right? If we continue to ask more students instead of stopping at 45, if we went all the way to 100 and the preferences were proportionally stayed the same, that means out of those 100 students that we asked, 40 of them would not be Dodgers fans, right? That's where these two numbers come from. And I want you to notice something. We can convey the same information either as a proportion or a percentage. This is a ratio, right? A ratio, 27 students are Dodgers fans out of 45 students, out of the total, right? That is the same as 60%. And then backwards, 18 of the students who said they were not Dodgers fans out of 45 total students asked. That comes out to 40%. 40% of students were not Dodgers fans. So these are the same. You can write this as a ratio, or you can write this as a percent. I'm going to leave you with this Velociraptor here, something for you to think of, and then we'll see you in the next one.